All right. Hello, everyone. This is Camille, CTO and co-founder at Starburst, and I'll be talking about powering interactive BI analytics with Presto and Data Lake today. All right. So in this presentation, I first want to introduce Presto for those who don't know what that is, and talk a little bit about Starburst and what we do here to sort of help enterprise adoption of Presto. The main topic of my presentation is the Delta Lake integration that we done for Presto, and then sort of show how we can combine Presto and Databricks, Spark, and Delta together in one data platform architecture, and how to efficiently use the best capabilities of both technologies. And then finally show real use cases where that combination actually delivers best results for your team. So with that, let's get going. So Presto and Starburst. Presto itself, it's open source, community-driven project. At its core, it's a high-performance MPP SQL engine. It was designed specifically to be geared towards interactive analytics and perform ANSI SQL analytics over large-scale data, ranging from gigabytes on the low end to petabytes on the high end. And the design goal for Presto was also to help with high concurrency queries and fast performance overall. One of the unique capabilities of Presto is that it provides full separation of computational and storage layers. So that allows you to scale those two independently, add more storage without adding compute nodes, and then boosting compute if you need to perform lots of analytics, and then scaling back when you don't need them at that capacity. So allows you to manage cost and performance elastically and cost effectively. Also, Presto itself is just a compute layer, right? It accepts a SQL statement, does all the parallel execution of the query, and then it's done, right? There's nothing in Presto about storing the data. So you have to kind of bring your own storage, and storage is most efficient, effective for your use case and most appropriate. So in a sense, Presto allows you to run SQL on anything. And with the powerful extension capabilities, you can actually connect to a variety of different sources and also write your own connectors to sources that are not yet available in the open source or commercially. The side effect of this is that you can also run federated queries, meaning that in a single SQL statement, you can actually refer to tables coming from different sources. And that's sort of allow you to do correlations of data coming from different sources and perform this interesting analytical queries that will otherwise be waiting for you to bring all your data into one place, which obviously is typically a long process, and you may hit lots of barriers, especially in the enterprise settings. Finally, you can deploy Presto basically anywhere. We've seen successful deployments of Presto initially on bare metal, on-premises systems, then in virtualized environments, then cloud. Now Kubernetes is really the way to go to deploy Presto in essentially any of those environments. So it gives you a lot of flexibility, and you don't have to be tied to any specific platform, and you can move Presto analytical system from one place to the other and go where your center of gravity for data is. So Presto has been around for some time. It's been about 7 years since it was originally developed by the team at Facebook and got initial adoption in large Silicon Valley internet companies, and then sort of progressively expanding to more and more companies globally different verticals and use cases. So you can see some logos here on the screen that just gives you a sense of, Presto is applied pretty much anywhere for SQL analytical purposes, and it's been sort of the fastest growing SQL engine among anywhere in the open source for sure. It can run at a massive scale. So some of the largest deployments, especially at Facebook, Uber, LinkedIn, Lyft, we're talking about hundreds of machines, putting petabytes of data and running hundreds of thousands of queries a day. So it's really, really impressive what those companies are doing and pushing Presto to the limits and on scale and performance. So now Starburst, we are the enterprise Presto company. We are the commercial arm behind the open source project, much like Databricks is for Spark. What we the value we are bringing to enterprise customers specifically is around simplifying the usage of Presto, provides you lots of security enhancements into integrations, data encryption, masking, permissions, integration with LDAP, Okta, Apache Ranger, and sort of other security-related protocols. In the enterprises, you typically have lots of different additional connectivity needs beyond just open source, open formats. You'll be talking about querying Oracle, Teradata, DB2, Snowflake, etc., etc. And those are all packaged in the enterprise distribution of Presto that Starburst offers. On the management side, as I mentioned, ease of use is super important for into enterprise settings. So we manage configuration, auto scaling, HA monitoring, and just deployment in all those different environments and simplified, orchestrate that effectively. And all of this is obviously wrapped into us providing support for Presto, and because we have the largest team of experts in the world, we have Presto creators behind the company right now, and provide hot fixes, security patches, 24/7 support. And the thing that's also very important, and that's also true for Databricks, like we are the leading contributor and committer to Presto itself, to the open source project, right? So we're driving the roadmap and enhancing Presto to get you more performance, more scale, more functionality in the open source. And then if you choose to go with our platform and managed enterprise offering, that's where you get additional benefits as well. Okay, so I've talked about how Presto can connect to many different sources already. So why data lake? We obviously got interested in Delta Lake when it was first announced by Databricks a couple years ago. Then subsequently when it was open sourced last year. And Delta Lake is really, really exciting technology for many reasons. So I just mentioned several of those here, which I think are fundamental. First of all, it gives you asset properties over the data lake. And this is huge, right? It's massive because you can now go and delete individual rows and update the individual rows and insert individual rows effectively over your data lake, which in the past was quite cumbersome, and people develop complex frameworks to do that. That's now simplified. Everyone can treat object storage as essentially a database table, which is amazing. That's how we want to work, and that's how Presto sees the world. So that's great. It's open on open source table format, so multiple different tools can use it. Spark obviously was the initial implementation. Now we have Presto. There is connectivity for Hive, and I suspect it will be much more broadly adopted in the future as well. The actual data underneath is stored as a Parquet file, set of Parquet files which is great because Parquet is very, very efficient format to store the data. It's columnar, it's compressed, it has built-in min-max indices and other performance optimizations, which is really great for performance. Delta supports object storage natively on S3, ADLS, and other object storage, which is where the world is going with when storing large amounts of data these days. That's amazing. On top of all those basic fundamental benefits, there are really great features around schema evolution and even time travel, allowing you to see what would be the answer to this query if you ran it like a day ago. And I think that's very interesting for many workloads, and especially in the analytics space. And then, just to sort of further show the benefits of Delta, having the dedicated metadata information that's outside of Hive MetaStore, having statistics on the data, that helps a lot with performance because you can skip the data and if you have data arranged in a special order, that also helps to speed up many analytical queries. So I think we all are very, very thankful to Databricks for inventing Delta and making that popular file format. It's getting lots of adoption. Many of our joint customers are also users of Delta. So it really made a lot of sense for us at Starburst to enhance Presto and allow it to also query Delta effectively. As I mentioned, Starburst developed a native Presto Delta Lake connector, and I would like to acknowledge great help from engineers at Databricks that assisted us with that integration and provided further details in addition to the official specification that helped to implement this effectively. So we decided to build a native connector written completely from scratch, right? So there used to be a legacy solution that allows manifest files and Hive MetaStore integration and simulate access from Presto to Delta, but it was very, very inefficient because it wasn't taking advantage of any of the inherent Delta Lake properties. So in this implementation, we actually natively read Delta transaction log. We perform data skipping based on the metadata read from Delta, and we are able to fetch statistics about the data and basically leverage those as an input to the Presto cost-based optimizer. And that allows us to effectively perform joins among Delta tables, as well as Delta tables and other tables coming from different sources. So it was really important to have this native integration built for Presto here. Okay, so once we built the very first version of that, we were curious, obviously, how that performs to this legacy solution, which basically treated Delta as a collection of regular Parquet files. So we ran standard TPC age benchmark, and across 22 queries in this benchmark, we saw on average for all the queries. And obviously, those queries are doing much more than just reading the data. So that overhead is in. The fastest query that we observed in this benchmark, which was a single table scan doing some aggregation, was actually showing 6x performance boost with the native reader. So that's pretty substantial. And once we get the validation that we've done efficient implementation of the Delta reader, we also share this with our as a preview with our early customers, and the feedback we got was actually even more enthusiastic because they were reporting speedups, over 10x for the native reader versus the previous solution. So just drives adoptions, helps with the performance overall, and makes users more happy to come back and run more queries. And do more analytics. So I definitely encourage everyone to try out this native integration of Delta with Starburst Presto. There's a little link and documentation link here on the screen. So, having that is great. Obviously, engineering addition, yet another connector for the Presto. But how you sort of tie all those things together, right? To work together effectively in one environment. And I thought I would spend a few slides on this topic, how to effectively leverage Databricks and Starburst one architecture. So the Starburst platform itself, obviously at the center of that is Presto as this fast SQL layer that's able to talk to many sources. What we've done, in addition to just leveraging open source Presto, we've built additional connectors to more sources. So I mentioned some of those are traditional commercial RDBMS sources are very common in lots of enterprises. Oracle, Teradata, DB2 being the primary examples. We enhance support for additional SP compatible storage engines for on-premises as well as the clouds. We run in all the clouds, obviously, today. And Presto can also talk to your modern NoSQL stores such as Mongo, Elastic, Cassandra, etc. Right? And sort of having one tool that can reach to all those different sources, both legacy and modern places where you may store your data, is really, really powerful. However, there's always challenge. Well, with all that diversity of sources, how to do it effectively, how to do it securely, and how to manage the whole experience for the end users, right? So that's what we sort of call, as part of our platforms, we call it a data consumption layer, right? And a big piece of that was building a global security mechanisms that will govern secure access to all those sources from Presto, and also from the users that are querying this data via Presto, and sort of managing permissions, masking sensitive information, ensuring data encryption, both for reading the data encrypted at rest, as well as encrypting data in a flight when it's moving from the source to Presto and within the Presto cluster, and then between the client tool and the Presto cluster, right? You can audit all the queries. You can have very fine-grained access control down to the table and column, and actually you can also apply row filters and further restrict access certain things. So all of those things are part of Starburst platform edition. And on top of that, we've done integrations and certifications with a number of your favorite BI tools, those Looker, Tableau, Power BI, Click, etc. And sort of enabling that, plus all the modern tools that can issue SQL, starting from Jupyter Notebook, Superset, Redash, which I think right now is part of Databricks. All those tools can talk and speak to Presto natively, and gives all the users power of the broad set of connectors and security features of Starburst. So that's on the Starburst side. And now this question about, like, I have Spark, I have Databricks, I have Presto and Starburst. Like, how do those things work together? What's the best way to effectively leverage both, right? And what we see in like real life deployments with our customers is that pretty much everyone who leverages Starburst and Presto, they also leverage Spark, and often that's Databricks Spark, right? And the reason is that I think those technologies excel at different things and complement each other very well. So if we are talking about streaming ingestion of data, we're talking about big machine learning jobs, artificial intelligence, obviously managing data lake, doing really, really heavy, long ETL jobs, all those things, whether you do it through just native Spark syntax or whether you leverage Spark SQL, all of those things are best positioned to happen inside Databricks and inside Spark, and Spark is the way to do this effectively. On the other hand, Presto really was designed and excels in high concurrency SQL. So if you're running tens and hundreds of queries at the same time, if you're doing some BI reporting, analytics, interactive database discovery using SQL, and you want to also federate different sources, right? So you have Delta Lake and Parquet files on S3 and Avro, but also relational databases, NoSQL engines. This is where Presto can provide a lot of value. And we feel that interactive, faster performance is enough of distinguishing factor that drives adoption of Presto and Starburst. And because we have now so many joint customers, we feel really compelled to really advocate for this joint architecture. Yeah. So if you look sort of holistically at the data ingestion analytics ecosystem, this is all coming together by having your raw data sources all being ingested via Databricks and Spark into data lake. These days Delta Lake specifically, right? But you can also just put your data on either Amazon S3 or Azure Blob DLS, and you can run all the machine learning AI, MLflow, or SageMaker over this data for those use cases. While if you want SQL over this data, plus correlate this information with lots of different data sources that are either RDBMS, NoSQL, and all over the place, they're like Starburst and Presto is the perfect answer, right? And provides sort of higher and more responsive, high concurrency, more responsive SQL access, and allows you to leverage all the BI tools and SQL editors and Redash, Superset, Jupyter Notebook, and your favorite tools for analytical purposes, for the more classical analytical purposes. In terms of deployments, this is very interesting as well. So these days, we highly recommend deploying Presto on a Kubernetes cluster. And in fact, I will be showing Presto deployed on Amazon EKS Kubernetes service later in the demo. But we see this pattern of Presto being deployed via Kubernetes on Azure, on AKS, in Google Cloud, GKE, also on premises. So we work closely with Red Hat and OpenShift platform for the Kubernetes deployment, and we see people deploying Kubernetes, pretty much anywhere. But as I mentioned, you can obviously do it in many different ways as well if Kubernetes is not yet adopted at your company. And so we simplify all that configuration, deployment, management sufficiently. So it's really very, very intuitive way to do all of those deployment and management, and it's simplified drastically to what you've been used to in the past. Okay, so now bringing all of this together, right? This is all great architecturally, technology. What's the real use cases that we can sort of show here, right? So the one use case that we want to advocate for, and we've seen this already being leveraged, is in a joint architecture, Databricks and Starburst. We have obviously some IoT data streaming from the IoT devices, streaming into a Delta Lake. We may have some data coming from classic ERP system. In hourly batches, we are moving this data from the application layer into again Delta Lake specifically, and we can go through all those different layers from ingestion bronze, refined silver layer of Delta Lake, and then to the aggregate store or the gold layer, right? Which is the best position for fast analytics. And Starburst can come in, all that, everything before happened in Databricks. Now Starburst comes in and allows you to run your fast, highly concurrent SQL and fetching data from your aggregate store, as well as reaching out to more or less refined source versions of those tables if needed, right? If your analyst, data scientist prefers to look at the very raw data, that's also possible from Presto, right? And now, while we have a lot of data being ingested into this data lake, it's not going to be everything you have potentially in your analytical ecosystem. We've seen a lot of companies coming with data lake strategies and having the center of gravity there. However, your RDBMS, traditional Oracle, Teradata, DB2, etc., are always there, and there is sometimes very interesting data there that you better correlate with the information coming from other sources. And for other data sets, like more textual data sets, say weblogs and user comments, unstructured, less structured data, things like Elastic or MongoDB are really appropriate ways and places to store them, right? And now, since your data is spread across so many places, you need the ability to query all of those at the same time, quite often, to arrive at the best insights that can drive your business forward. And this is what we can provide here with Starburst and all the connectors we have for those platforms. So as I mentioned, we'll be doing sort of the real-time ingestion of event data, and I'll be showing this in a demo in a moment. We'll be doing also the hourly jobs of moving the more traditional enterprise data, and then reaching out to auxiliary data sources as well. And we sort of modify this and refine this, and we sort of prepare this data for further analytical needs as appropriate in our overall architecture. So we're, obviously Starburst here provides this single access layer, right? It's no longer true that you have all the data in one place, so there's no single source of truth for data, but there's single access point to query this data, right? And that sort of virtualized query environment is where the power of Presto is, right? So you can leverage the power of the appropriate data stores for your data and query data right now, rather than wait for maybe ETL job to bring this Oracle legacy data or X data into one place, because it's hard to sort of imagine, how you need to modify and prepare this data sometimes for your analytical purposes. If you're given access to this Elasticsearch, you can actually push down some processing there and find appropriate data by doing the text analytics essentially, and bringing that back to the relational world. And Presto Starburst can provide sort of a global access control for the sources, so your analysts are appropriately privileged to the data that's sort of meant for them to be analyzed. So now in this demo, obviously the end users will be leveraging BI tools, SQL editors such as Looker, Tableau, Power BI, leveraging connectors like JDBC drivers or DBC and plugins for other languages. And we sort of now want to show all of this in a demo and briefly comment how you put all those things together. Okay, so we are in a Databricks notebook here, and we have obviously S3 bucket mounted, and we're setting up a structured streaming ingestion from a Kafka topic into a stream that will then save into a Delta table. So setting up here, making sure the connectivity is live, and we started the stream, checking the schema, making sure it's matching what we expect. And now basically issue a command to receive this data and save into a Delta Lake and verifying that the stream is actually live. Okay, so we have ingestion going on. Now we are switching to a dbeaver, which is a SQL editor tool in which we have mounted all different data sources such as Delta Lake, and we'll be sort of trying out to query Delta via Presto from dbeaver client. That came up very quickly, as you can see. Now showing the same for Elasticsearch. So this is Elasticsearch set up in Amazon Cloud. We can query that very quickly as well individually. So that's perfect. And then on Amazon RDS, we have an Oracle system with some customer information. And that's sort of together, now bringing all this together into one SQL statement. We can sort of correlate this information and do the join between orders, customer, line item, and parts, and execute the SQL. And here in the Presto web UI, we can see how query is progressing. We can monitor the state of the cluster and see the progress of this join, pretty complex join query with 4 tables, and then see the results back at the dbeaver screen here. Now, switching back to a more classic BI tool, Tableau, we have a dashboard. We are sort of correlating all of the same information and sort of displaying the orders in a geographical dashboard. Visualize which orders are coming from which countries. So this actually pretty quickly. We have another statement being run, and all of this is now sort of reflected on a dashboard again. And the difference is here that we have a virtual view of federating all the sources, but it's still the same Delta, Elasticsearch, Oracle as free. And now, in addition to the dashboard, you can also run a classic report. Here we are showing customer per country per region, and display that in a classic report style visualization. And all of this is interactive live queries against the real data coming from all those different sources during query time. And so I hope that demonstration was helpful, and you see the power of both tools together. And really thank you all for attending, and really happy to answer any questions.